So back to Robin Millar's paper. So some of his key findings, we've talked about the fact that, that people do have some confidence about teaching of energy, but actually some of the research might indicate that there are some difficulties. He also talks about in order to communicate the scientific idea to young learners, we have to simplify it, but still ensure that we teach it as clear and as useful and provides a sound basis for developing a fuller understanding later. So we'll talk more about that, but there's some compromises about what that might look like when we first introduce some of the ideas. The starting point is to ensure that as many science teachers as possible have a clear understanding of the scientific energy concept and are aware of the issues about energy teaching that have been discussed and debated. So that's really what we're trying to point out to people, that there are these issues there. If we're all aware of them, then in our teaching, we can actually point them out to the students and actually hopefully get better outcomes for everybody.
When we come to simplify, some of these things, we're deciding on, boundaries and things like that, and what we're how much we're willing to sort of stretch the truth, as it were, in different ways. And a lot of that may well be down to you as an individual teacher. You will know the kids that you're teaching. You will know, how they receive different ideas. You will know your background. You will know, the context that they're in. And so we're not necessarily talking about everybody deciding to make the same decisions all the time.
Yeah, I think that's a very good point. We're just trying to give people, I guess, a consistent message around what some of the issues are, so people, when they're moving forward with their teaching, do know that there are those challenges there. So onto the specific details. So some of the reality energy is something that flows. We see this in many contexts, many documents, many of the concepts, developments that have been put out in various textbooks. And this is problematic because what we talked about in that survey was that, in fact, energy is an entirely abstract mathematical concept, and that the key point of it is that it is conserved. Millar argues that talking about energy as though it were a kind of quasi-material substance, though, that can be transferred from one place to another, so this idea that it could flow, is almost unavoidable. And part of that, I think, Gary, is, problem with our language. When we start talking about energy transferred and transformed, and we're going from something that's got potential energy to something that's got kinetic energy, that there's this natural language barrier that we have, that our minds almost take us from the story of that there's this stuff that flows from one thing to another. But what Millar has found out, that it actually for lower secondary students, 11 to 14-year-olds, actually those ideas, they're okay. They're not going to cause any sort of long-term damage, as long as we don't sort of push them, I guess, in terms of being rock solid ideas, Gary. I guess that's probably we treat them carefully and accept them for what they are at that point, they're fine.
Yeah, and I think it is almost unavoidable. I think it's I think the maths sort of plays into that. As soon as we start doing strings of equations, mgh equals half mv squared, it looks like something is flowing from one side to another. It looks like you've got a chain that you're passing something along. Very difficult.
Yeah. But hopefully through the series of these videos, we'll be able to present some ideas that, will at least shift people's thinking towards that actually there are there are ways around those problems. But I think we just have to accept that certainly in the English language, that, in the representations we've got, he's quite right, it's unavoidable. And you can spend a long time telling kids, oh, it doesn't. Well, that's probably, A, a waste of time, and B, probably just going to embed the idea into their heads anyway.
I mean, one of the ways is we can avoid it is if we were to replace the word energy with equivalence. But then we're on to a language issue.
Yeah. That would be a lovely idea, but I think it's probably unlikely at this stage of its development. So, right, so where to from here? So a bit of an historical perspective. I think it's useful to think about that. It's probably a nice segue into that. So the word was adopted and used by scientists working during the period of sort of 1780 to 1850. So these are recent developments in terms of, our own understanding of these concepts. And, they developed the formal mathematical theory of, involving heat and motion and this idea of its capacity to do work. So a lot of that stuff out of the Industrial Revolution really drove some of these ideas. But since then, however, the term energy has remained in everyday use. So it came out of that formalism, and now it's taken, with its original pre-scientific meaning, and obviously it's got this general meaning in everyday use, which, everybody uses this term. And that actually, we have that problem with a number of terms in physics, and energy is probably, right up there in terms of it being problematic for us, in terms of when we actually want to be able to use it to calculate something, to find something else out. So we all become, for those of us who are trained in physics and science, we know that when we're talking about energy to our neighbor, or somebody that is having a conversation with somebody, that we mean one particular thing. And when we're talking about it in a different context, inside the physics classroom or the laboratory, or inside some sort of science context, we have to know when we're switching between these ideas. And I think we need to tell the kids that that's actually fine, Gary.
Yeah, I mean, one of the we say things like you're full of energy,
yeah,
which makes it sound like there's a vessel and you're pouring something into it. And the other thing we have to be careful of is circular references. So the capacity to do work. Well, what's work? It's energy transfer, and then
yeah, it doesn't help. And I think we've probably all fallen for that trap. It's actually really problematic. But I think if we know these things and we can tell the kids, it's fine. I mean, it's like the argument with weight and mass, right? People are going, what do you weigh, Gary? And, what do you weigh, David? I mean, it's fine, but, we're not going to tell them, well, we weigh, 875 newtons, because somebody will look at us very strangely and think, what are you talking about? They might think we weigh 875 kilos, but that would be quite amusing. So what are the implications of some of this stuff? So this then poses problems for how we teach about energy, when we need to avoid the sort of looseness of our own language and our everyday discourse. And we need to develop a model, of this sort of intangible substance. And we have to accept that the kids are going to think about it flying from place to place, because our language, we've talked about this already, but that does sort of help us in some sense, because the key idea is this conservation of energy idea. So Millar points out that actually the language, in some respects, the kids see it as a sort of, flowing material. Well, the material is not going to disappear. So in some ways, I guess that helps us, doesn't it?
Yeah. I mean, that, as we say, it's just really difficult to get away from it in the idea of something flowing. And in fact, although the sort of, from a physics point of view, it's an issue. I mean, as another physics teacher pointed out, we've produced lots of physicists and engineers who do things like build bridges using a model that isn't quite right, but works in beyond an everyday setting.
Yeah. So we can get worried about things, and what we want to focus on around is, the conservation law is actually the fundamental idea, and some of the language stuff, helps us in sometimes and doesn't help us in others. So what Millar also points out, that in some situations the forms of energy, so these ideas about gravitational potential energy, chemical energy, tidal energy, kinetic energy, that they can actually lead to some quite significant incorrect analyses of processes. And when you read the paper, he unpacks a particularly good one about fuel in relation to cars. And so we'd strongly encourage you, when you read the document, when you get to that, you may well find actually that really, really helps people to actually hone in on where the problems are. So most senior and primary pupils will know the word energy from the everyday discourse, and many will associate it with fuels and food. And that can't be helped. Right? We have, Gary mentioned, you're full of energy, the energy drinks. I think one of the key things here, I think, Gary, is that we need to make a particular effort to try and distinguish between a difference between fuel and energy. So Millar's example of the car being full of petrol and it being consumed is often misconstrued with the ideas of energy. because when you actually unpack it in terms of the energy, you actually got to look a little bit deeper to see what's going on. So we want to avoid talking about energy use and energy consumption, because that works away from the idea of conservation of energy, and try and talk about fuel use and fuel consumption. So Gary, I don't know if you want to add anything to that.
Yeah, I mean, fuel's a nice concrete idea. The students, they can see fuel.
Yeah. Yep.
They can touch, well, not obviously not the stuff you put in your car, but they can touch it. Having that more concrete basis allows you then to talk about the physics and chemistry of what is really going on, rather than us just using up some magical stuff, or consuming some magical stuff. We can talk about what's going on with bonds, digestion, etc., which is really what we want to do, rather than just thinking about this stuff flows from here and this happens because of that's not the way we want to go.
So I think that's a relatively sort of, once one is tuned into that, I think that language change can actually be quite significant. So what energy isn't? I think that this is a very interesting part, and possibly, certainly in the first iteration of the achievement standard, one of the concerns that I had was that there was this implication that energy drives change, and is a fundamental way to explain things. So, a ball keeps moving because it has kinetic energy. Petrol makes a car go because petrol has energy. A stone falls because it has potential energy. Energy is not a mechanism. We actually need other ideas like force, etc., to actually explain how and why things happen. Looking at an event from energy point of view might throw some light on some aspects of it, but it doesn't tell us how that actually happens. Second reason is that energy is conserved. So if a process runs in one direction, why wouldn't it run in the other direction? From energy's perspective, it's quite possible. We often use energy as a mechanism to explain phenomena, and in some contexts that's actually quite a powerful way of doing things. But in many cases, actually it doesn't add anything, and actually there may well be a much better way of explaining what's going on. Gary, do you want to add anything to that?
Yeah, just avoiding because, and then something to do with energy is it's not. It can't be a reason for something to happen, because it's not a real thing.
Yeah, it's not a real thing, and nothing's actually, the amount of energy hasn't changed. So
overall,
that stone had its energy, and we could say it's got some magic number, and that magic number doesn't change. So in fact, if anything, energy is the it's rather boring idea in that respect. It doesn't actually help us in that respect. It's a very powerful idea, but not for that reason. So where to from here? So in Millar's paper, we're not going to unpack everything in it. It's probably about a 15 or 20 minute read. It's very well written. It's written in very straightforward terms that everybody from very experienced people working in this area to new teachers will get something out of. He points out a few teaching methodologies. We'll point out some other ones actually that we think that might be of particular value. So our big endeavor is to try and present appropriate ways to teach the concepts associated with energy that make the teaching more interesting, make the kids feel more connected to this rather mysterious sort of idea. And actually, in one particular case, will actually, really does help people think about things like what a system is, which is really important in physics, and probably one of the hardest ideas I've often found in teaching energy, and that is the idea of work. One of the particular methods that Matt McGovern will present in this series of videos will be a methodology that actually gives you a really strong sense of how work works, if there is such a thing. So Gary, I don't know if you want to add anything further to that.
It's just, I think that the idea here is we want to keep the discussion going. We want to keep people thinking about how they're teaching energy. We're not particularly trying to dictate how that's done, but there are some definite issues that people should be aware of, and that they'll end up making their own decisions, obviously, about how they decide to teach this. Some of the ideas in the standards were a little bit tricky when we looked at them, but then there's other aspects that are really quite good. So for instance, presenting just the idea of energy concepts, So that there's even if you're doing even if you think that forms and transfers are the best way to do that, then that can still sort of be accommodated. There are issues with those approaches, but it's as we said, it's not for us to be pushing people towards doing things in particular ways.
Okay, so that's probably the end of our first short video. There'll be more to come. We've outlined a couple of little things there that hopefully will get people thinking about things. We really strongly encourage you to read Millar's paper. It's light reading, but it's significant. It presents things in a really, really good manner. And hopefully you find that the next few videos, which will be more about, actual teaching strategies, the language, practical activities. We'll have some different presenters, not just us two. And we hope this is a valuable piece of professional development for our teachers. Gary, I'd like to thank you. And till the next time, everybody. Thank you very much.